Okay, so let's unpack this. Imagine you're building something huge, really complex, like a skyscraper.
Mm-hmm.
You wouldn't wait till the whole thing's up to check the beams on floor 10, right? You check as you go.
Exactly. That'd be madness otherwise.
Well, today we're diving deep into something similar in software. Module testing. It's basically checking the individual pieces.
Yeah, the subprograms, classes, procedures, those small building blocks.
Instead of trying to test the entire massive program all in one go.
Precisely. And what's key here is that it's often white box oriented.
Meaning you look inside the code itself.
Right. You're looking at the internal structure, and the main goal, well, it isn't just proving it works.
Oh.
Fundamentally, it's about trying to demonstrate the presence of an error. You're actively hunting for flaws in that specific module.
So finding the problems, not just ticking a box.
You got it. So our mission for you listening is to get a real shortcut to understanding why this step is so critical for, solid software.
Okay, so why put things under such a microscope? Why this granular approach? This is where it gets really interesting, I think.
Well, it boils down to probability, really.
How so?
By focusing on these smaller chunks, your chances of actually finding errors or bugs just shoot way up.
Makes sense. It's easier to spot a faulty brick than figure out why a whole wall is unstable later on.
Exactly. And it's not just about finding bugs more easily, it's also about efficiency.
Ah, right. You mentioned teams working together.
Yeah, this approach allows for real parallelism in testing. You can have multiple modules being tested simultaneously by different people or teams.
Which must speed things up significantly.
Hugely. And the overall complexity of testing becomes much easier to manage. You're dealing with defined, smaller pieces, not this giant, tangled web of code. Have you seen teams really benefit from that parallel approach?
Oh, absolutely. It avoids that big, painful integration testing phase where suddenly everything breaks. It's like having lots of mini inspections along the assembly line.
That's a great analogy.
So, okay, we're sold on the why, but how does it actually work? How do you do module testing?
Right. It really starts with designing a good test case.
And what goes into that?
Well, a tester needs to look at two main things. First, the specification for the module, like what is this thing supposed to do?
Okay, the requirements.
Yep. And second, crucially, you need to look at the module source code itself. How did the developer actually build it?
So inside and out.
Exactly. You often start by analyzing the internal logic using those white box methods we mentioned.
Looking inside the code.
Right. And then you usually supplement that. You add black box methods to check if the module behaves correctly from the outside, based purely on its inputs and outputs against that specification.
Okay, covering all the bases. Then what? Once you've tested these individual modules, you have to put them together, right?
That's the next step, yeah. Combining them. And there are basically two main ways people do this, incremental and non-incremental.
What's the difference?
So the non-incremental method is kind of the Big Bang approach. You test all the modules on their own, independently.
Okay.
Then you combine them all at once and test the whole integrated program.
Seems simple, but I sense a catch.
Well, it can require more work, potentially. If you find bugs only after everything's put together, it can be harder to trace where the problem started.
Right, debugging could be a nightmare. So what's the alternative? Incremental.
Yeah, the incremental method is more gradual. You test a module, then you add another one that interacts with it, test that combination, add another, test again.
Ah, like building up step by step.
Exactly. It's a stepwise retesting approach. It helps isolate problems much earlier as you add each new piece.
And are there different ways to do that incremental approach?
Mm-hmm.
Huh.
There are two main flavors, top-down and bottom-up.
Okay.
Top-down starts with the high-level modules, the main control structures, and you gradually add the lower-level ones, they call. You often need things called stubs here.
Stub?
Yeah, they're like placeholders. Simple bits of code that simulate the modules that haven't been added yet, just so the higher-level ones have something to call.
Got it. And bottom up.
That's the opposite. You start with the lowest level, most fundamental modules, ones that don't call anything else, and build upwards.
Okay.
And for that, you often need something called a driver.
A driver. Like for hardware.
Sort of, but simpler. It's just a temporary piece of code you write that acts like the calling environment. It feeds test data into the module you're testing and captures the results, because the higher level stuff isn't there yet.
Okay, so drivers push data in for bottom up. Stubs are placeholders for top down. Makes sense.
Precisely.
Now, this does bring up something that often causes a bit of head scratching. The difference between unit testing and this module testing.
Ah, yes, a common point of confusion.
From what we've discussed, it sounds like module tests are usually written by a tester, maybe after the developer's done some initial coding.
That's generally a key difference, yeah. Unit tests are typically written by the developer themselves, often while they're actually writing the code, or right after.
And they test smaller pieces.
Much smaller, usually. The smallest testable units of code, like an individual function or a single method within a class. They're often tested in complete isolation.
Whereas module testing,
Module testing might involve combining several of those units that work together to perform a specific function, or it might test a somewhat larger logical block of code. It's often a step up in scope from a pure unit test.
I see. So unit is developer-focused, super small, often done during coding. Module is often tester-focused, a bit bigger, maybe combining units, done after some code exists.
That's a good summary. And that's also where you might run into challenges like properly using test doubles.
Test doubles, like stubs and drivers.
Exactly. Those are types of test doubles. Also mocks and fakes. They stand in for real dependencies your module needs, like a database or a network service. If you don't set them up right or misunderstand how they work, your test might pass.
But the module might still fail when it interacts with the real thing.
Precisely. So effective module testing often requires a pretty good understanding of the code itself, not just the specification.
Right. So wrapping this up for you, the listener, module testing is really your strategic weapon for taming complexity. You break big software down into manageable chunks, test them thoroughly.
Which massively boosts your efficiency, helps you find bugs earlier, and just brings clarity to the whole development process.
Definitely sounds essential.
And thinking ahead, it raises an interesting question, doesn't it? As software gets more and more complex, integrating with AI, constantly changing, how do these core ideas of module testing need to evolve?
How do you test modules in systems that are dynamic, interconnected, maybe even learning on their own?
That's the challenge for the future, I think. How do we adapt these principles?
Food for thought. Thanks for diving deep with us on module testing today.
Academy Podcast, where ideas ignite and futures forecast. Dive into realms of wonder vast. CTSS Academy Podcast.